Hi there. We are in your new Unit 3 notes packet. So if you are out today, you don't have this quite yet. However, I do want to go over this with you. You can jot these down on a piece of paper, and then you can either transfer them into your notes or just kind of like keep it with your notes for that time. That would be great. These are on page number 3 in your new packet when you do get that. Notes for solving for today. This is the bottom part of the paper. We are going to actually talk about solving one-step equations. And my pen just went crazy on me. We're going to start talking about these one-step equations here. And our biggest note for solving is to make sure that we are undoing the operation. So whatever's there, we're going to think about what operation undoes that. So for example, if you have addition, you'll be using subtraction. If you have multiplication, you'll be using division, and vice versa on those. If you have subtraction, you'll use addition. We're going to start with easy problems here that you can totally do mentally so that I can show you what our steps and our process are going to look like. So in the first example, I have x plus 12 is 15. It makes sense that x in this case, which is our variable, would have to be 3 because we know that 3 plus 12 is 15. We're going to show this though. We're going to use this equation or equal sign as our dividing line. And our job is going to be to get this x all by itself. The variable is a letter, and I like to say that letters like to be loners. They like to be all by themselves. So over here with your x, I notice that there is a plus 12. In order to move that plus 12, I'm going to have to subtract 12 or minus 12 to get rid of it. The problem is on an equation, if I do it to one side, I also need to go ahead and do it to the other side. Since we're doing addition and subtraction, just like you did in elementary school, we'll draw that line going across, and we're going to go ahead and slash those out because a plus 12 and a minus 12 are opposites, and we've learned that together they give us a big fat 0. So now you're saying x plus 0, which is really just x, is equal to 15 minus 12, which is 3. Which goes back and makes sense because 3 plus 12 equals 15, so we've done this one correctly. Over here on this next example, I'm going to go ahead and drop a line down. I'm going to look for that letter again. Letters are loners. That letter is R. The things over there with R is a plus 5. So I want to go ahead and do a minus 5 to move it. Keeping things balanced here, I also need to do a minus 5 over there. That leaves us over here with R because those are opposites and cancel out. And 32 minus 5 is going to give me 27. If I go back here and I plug that in, 27 plus 5 is equal to 32. So again, I did this correctly. In this next one, I see x plus a negative 4. We want to actually try and avoid having double signs like this. So if I'm adding a negative 4, that really just means that I'm doing x minus 4 equals 11. X is right here. I see the minus 4 with it, so I'm going to go ahead and add 4 to both sides, which will leave me with canceling those out, x equals 15. I am going to be a really tough stickler about drawing this line down for the time being, showing that you're adding and subtracting across here, drawing that line across, and then writing out your full answer just like this. In the next example, I see again that double sign, negative 10 equals, and then minus a negative would really become x plus 3, because remember we are adding the opposite. So again, to get my x by itself, I have a plus 3 here, so I'm going to do a minus 3 on both sides. X comes down. A negative 10 and a negative 3 is going to give me a negative 13. And if I go back up here, a negative 13 plus a positive 3 would give me a negative 10. So we did that correct. That's how we can check our answer. Last one here, I'm going to rewrite as x plus 4 equals negative 2. X wants to be by itself. There's a plus 4. So to undo the plus 4, I do a minus 4. Doing that on both sides, I get x equals negative 6 over here because negative 2 and negative 4 gives me a negative 6. Last one here we have is a multiply one. So you have 5/9 times x. To undo this, we would divide. But when we divide by fractions, remember we actually multiply by the reciprocal. So I'm going to do that on both sides. When I multiply by the reciprocal, this is actually going to give me the 9's cancel out, the 5's cancel out. So 1 over 1 is just 1x, which is really just x. I'm going to do 20 divided by 5 is 4 times 9 is 36. So 20 times 9/5 is 36. That's the end of your just one-step equations that we're talking about for today. We'll continue on with these in a little bit. We'll talk about two-step equations, but I just wanted to give you kind of the layout for what we want these to look like.